Okay, so this tutorial is for geometric design. This is the last of our topics for Unit 11. And again, this one was from one of the ones I created, so it has the standards on there, how it relates to our curriculum. And it has some vocab. So the standards, first we want to figure out, give an informal argument for the formulas for circumference of a circle, area, volume, and such. So this is really, this lesson really kind of incorporates all the rest of the unit, because it kind of goes through basically applying these formulas and then deriving the fact that, remember, volume is like a base shape. So let's say it's a cylinder, it's a circular base, and then timesing it by the height. So that's how we come up with the volume formula, or cone, pyramid, such things like that. So and then the second one is using Cavalieri's principle for the formulas for area and for volume, really. But there's a short video on the website, on my website, for how to, or that shows Cavalieri's principle pretty well. It's difficult to do it with this, but basically for area, if you have something that has the same, two objects that have the same base dimension and the same height, so the top point to the very bottom point is the same, then if they maintain thickness at every point, even if they are offset from each other, so like at this point here along the figure and this point here, the widths are the same, then they have the same area. So two triangles that have a base and a height that are the same, even if the base is here and the height is outside of the triangle, they're going to have the same area. And that's what the principle is basically saying, and that's true even for volume. If two solids, let's say in a rectangular prism format, so I have two blocks here, they're coming apart, but even if so the volume of these two blocks, these two coasters, is the same even if I shift this over a little bit. Okay, so even if I shift it like this, even if it's slanted, the volume is still the same, because really you're just doing volume times the same cross-sectional area every time you move up the figure. So volume equals the cross-sectional area times the height. So the height is, as long as the two objects are the same height, even if you slide it over like a coin, a stack of pennies, even if you were to take it and slide it over, it's going to have the same volume, even if they're not all in line on top of each other. So then our vocab words here is dissect, is just to cut up in order to study by parts. Cavalieri's principle, again, there's a video for the principle on my website. If two solids have the same height and the same cross-sectional area at every level, then they have the same volume. Okay, that's true for area too. If two solids have the same base and have the same height, but the same base at every level, then they have the same area, the same width at every level. And then an oblique figure is just a slanted figure. So again, if you had that set of coins and you slid it over, that would be an oblique figure. But again, it's going to be volume calculations the same as if it was a regular figure. So the first problem on here is just to determine whether which of the following sets of shapes would have the same area. So what you want to do is determine, okay, they all have the same height, and you would look at the bases, or the width of every figure at every point. So right here, any width that I look at, consider it's the same on both of the triangles. So part A would have the same area. Those two shapes would have the same area. Same thing with this rectangle. If I look at this width there, it's the same. If I look at the width here, it's the same. And if I look at the width here, it's the same. So these, the rectangle and the parallelogram would have the same area as well. Okay, and if I look at this last figure, if I do like something close to the top here to do this versus this, this one's not quite as long as this. So these don't have the same cross-sectional width every time, but they are the same height. But if they don't have the same width and are the same height, then they're not going to have the same area. So this part C is not going to be the same area as the others. Okay, and so that's it for the first part, for the Cavalieri's principle parts. Before we get into the next set of stuff, I just want to recap, because we've done volume and surface area, but it's been a long time before spring break that we did this. So I just want to go back over the volume for different shapes and the surface area, well, mainly the volume. So we have prisms and cylinders, which remember are shapes that maintain thickness throughout. So a prism might be rectangular, so we can draw two squares or rectangles and then connect their corresponding edges. So I might have a rectangular prism, or I could have a cylinder which has just the circular bases, but it's still maintaining thickness. So remember, all of our prisms have two bases. Prisms and cylinders have two congruent bases that are parallel to each other. So if I were to set this like as a tissue box, the left and right sides are the same exact side. So those would be, or you can do the rectangles as the bases. But they have two congruent faces, and then it maintains its thickness throughout. Same thing with the cylinders. Two congruent bases, and it maintains this thickness throughout. So any kind of prism or cylinder, the volume is going to be BH, where B is the shape of the shaded part or the shape of the base. Okay, so if the base shape is a rectangle, then you would do a rectangle area here times the height. So remember, some examples is if it's a triangular prism, then my area would be area of a triangle for the capital B times the height of the prism. So I'd be putting in the area of the triangle 1/2 BH times the height of the prism. Remember, these H's are different. This is the H of the triangle, the height of the triangle. So that would be like this H in this base. And then the height of the prism would be the distance between triangular congruent faces. So the distance between these would be the second H. If we had a rectangular prism, we would just put in BH for the rectangle formula. So it would be BH and H. And again, those bases could be different. So those heights can be different. So the height here is the height of the rectangle, so the base and the height of the rectangle, versus the height here is the height of the actual prism. And then it could be any base shape. So it could be a trapezoid, and I could put a trapezoidal prism, and I could put a trapezoid here. Or it could be a cylinder. And remember, for cylinders, because they have a circular base, you would put circle in for the area formula. And you would do pi r squared times h. Okay, so those are your options for volume of any kind of prisms or cylinders. If we're doing the volume of pyramids or cones, it's the same formula with the 1/3 in front, or you can consider it to be the same formula divided by 3. Either way, they're the same thing. So remember when we did the demonstration in class where I were to take two objects that have the same base, so maybe a cone and a cylinder, and the same height, the cone fit into the cylinder, like if I poured water into the cone, it fit into the cylinder 3 times. So basically take the same area that you've been doing, but you just divide by 3. So for the triangular prism, I'm not going to attempt to draw the pyramids and cones, but if you need to see a visual of that, you can YouTube what those look like. Google what those look like. So that this is going to be the 1/3 triangle times the height of the prism. Sorry, pyramid. We're doing pyramids now. Okay, so it's the same formula as the other one, but if it's a pyramid, you just divide it by 3 at the end, or you can times it by 1/3 at the beginning. Okay, and so on for the other one. So we would just add the 1/3 BHH, and then this one would have 1/3 for the cone, pi r squared h. Okay, so again, that's for the cone, this is for the rectangular pyramid. So those are our volume things that we did, and then we did surface area last week or last class, and surface area, sorry, not surface area, spheres. The sphere volume is just 4/3 pi r cubed. Okay. That's the only different one besides prisms and pyramids. So really on the formula sheet for the geometry course, they only give you 3 things. They only give you these 3 things. They don't even tell you which one, for the Florida formula sheet, they don't even tell you which one goes with which. They just assume that you remember that prisms and cylinders are just capital BH and you're plugging in different base shapes. Pyramids and cones are the 1/3 BH, and then the volume of the cylinder, of the sphere, sorry, is the most different. It's got the pi in it because you're dealing with a circular figure. Alright, so then this part you're just using applications, and I'm just going to do a couple that are maybe a little just random ones to choose. Actually, they're all kind of difficult because I think word problems just makes problems exponentially more difficult than they originally are. But a couple that have like little tricks and stuff in them. So let's do number 3 first. A cone and a sphere have the same radius. The height of the cone is twice the length of the radius. How many cones would it take to equal the volume? So I was looking for that word which tells us which formulas we're using. So the volume of the sphere. And so we're looking at the volume of the 2 shapes were the cone, which was 1/3 because it meets at a point at the top, pi r squared h, so circular base, that's where the pi r squared is coming from, and then height of the cone, versus the volume of a sphere, which is just 4/3 pi r cubed. Okay, and then they tell us they have the same radius, so r is the same, and the height of the cone is twice the length of the radius. So we can write an expression for the height of the cone. Height is in math is the equal sign, twice the length of the radius. So h equals 2r. So in this formula for cone, we're going to substitute in 2r for the h. And the sphere formula stays the same because it only has radius in it. Okay, so now these formulas have both have just pi, radius, and a fraction. So if I move the 2 to the front here, 2 is really multiplied by 1, they're both in the numerator, so it's 2/3 pi r, and then we have 2 r's here, and then another r multiplied by that, so it's r cubed. So 2/3 pi r cubed. And then the sphere is 4/3 pi r cubed. So how many cones would it take to equal the volume of a sphere? We need to figure out this times what factor would equal this. Well, they have the same denominator, so all we need is to multiply the numerator by some number. And to get from 2 to 4, you just have to multiply by 2. So it would take 2. I don't know what I was about to write there, so just 2. 2 cones to equal the volume of the sphere. Okay, on number 4, you're just finding the volume of a tilted prism, but applying Cavalari's principle, the tilted prism volume is the same as the volume of the prism as if it was straight up. So you would still just do the volume of a rectangular prism. And the one thing you want to be careful about is all of these have to be the same measurement, like units of measure. Right now we have inches, and then feet. So we want to convert them to the same measurement, and we know the conversion for inches to feet is there's 12 inches in every 1 foot. So if we use that conversion, we can use it in chemistry. You would start off with whatever you want to convert. So you'd start off with the 4 feet, then you would put the factors in whichever way you need them to cancel. So we need feet to cancel with feet, so we put the feet down here, and we put the 1 for every 12 inches. Okay, so the units here will cancel and we'll be left in inches for our answers, which is what we want. And then because the 12 ended up in the numerator, we multiply. So 4 times 12 gives us the 48 inches, and that's going to be our amount of inches that the height is. So instead of using this 4 feet here, we're going to use 48 inches. Okay, then we would do the volume or the area of the base shape, which is length times width. Okay, so it's a rectangular prism, so we're going to do 43 times 92, and then we multiply that by the height. This height is the vertical distance. It's not talking about the slanted. If they had given us the slanted, then we would have to find the vertical distance, but they've given us the vertical, so we're just multiplying capital B times h, and then h in this case is 48. So our volume after that just becomes all those multiplied together. So 189,888. And it's inches cubed. Okay, so just be careful for units that all your units are in the same. All the measurements, linear dimensions are in the same units. If not, then just convert them to the same. Okay, so I'll let you do number 5 and 2 on that page. Going to the next page for geometric design. Okay, there's a couple problems on here that that you'll have to solve. The first one, I just want to set it up kind of. So the Columbia Records unveiled that the vinyl record in the Waldorf is all of that is extra information. Okay, so there's basically some records that are in 2 formats for 15 records. So one of the stacks of 15 records is 10 inches in diameter. So if we have records here, the diameter is 10. And the other format for the 15 records is that the diameter is 12. If the thickness of one vinyl record is 0.2, so I'm going to try to attempt to draw this as 0.112 inches, then determine the difference in the volumes between them. So there's 15 records and they're each 0.112, so you have that really like 15 times. Okay, I'm not going to draw it 15, I'm just going to do times 15. So 0.112, you're going to times that by 15 because there's a stack of 15 records. So that will give you the height. Okay, so once you do 0.112 times 15, that's going to be the height of the records. Okay, so 1.68. inches. And then the other one, the records are the same thickness, they're just a different width. So this is still 1.68 for the height. Okay, so then you would want to figure out the volume of each of those cylinders. So the volume of the 10-inch one. For a cylinder, remember it's going to be capital BH, and the base shape is a circle. So we're doing pi r squared h for the 10-inch one and for the 12-inch one. Okay, the radius for this one, if the diameter is 10, is going to be half of that, so 5. And the height we said was 1.68. And the radius for this is going to be half of 12, or 6. Okay, so if we do the first one, and I'm going to store these in the calculator, so pi times 5 squared times 1.68 gives me like 131.9, and I'm going to store that in spot 1. And then if I do the other one, pi times 6 squared times 1.68 is about 190.00. So I'm going to do the larger one minus, and then I'll recall what was in spot 1, equals, so it's about 58.06, or you can just do 0.1 inches cubed is the difference. So you subtract them because they want to know the difference. Okay, so these word problems, you're just basically trying to figure out what the setup is, and then you're using a lot of volume, and then on the bottom part you're going to be using a lot of area too. So the next one though is a little bit of a review from things we did in the previous units in Unit 7 way back before Christmas break. So we're going to do number 7, and then I think the rest I will let you try it, and then if you have questions, yeah, feel free to let me know. Okay, triangular prism has an isosceles right triangular base. So isosceles right, it's a triangular prism, so we have triangle here, Maintaining thickness, it's isosceles, which, remember, that word means that two of the sides of the triangle are the same, and it's also a right triangle. So it's got a right angle, that's why I drew it that way, and then these two sides are the same. Okay, it can never be the hypotenuse the same as something else because the hypotenuse is the longest side. There's only one right angle, so the 90 is the biggest angle it could be. These have to be less than 90 each, or otherwise, if these were already both 90s or more than 90, then we'd be over our 180 for our triangle angle sum. So the hypotenuse of that is the square root of 32, and the prism's height is 12, which just means the distance between the triangular faces. So a square prism has a height. Okay, it's also got a square prism in it. The square prism has a height of 12. Okay, I'll make these my bases. So my height is 12, and its volume is equal to that of the triangular prism. So these have equal volumes, and they want us to work backwards to find the square base dimensions. So they want to know what this and this are, and they're the same thing. And they want the answer in simple radical form. So, just thinking about this problem, we're going to have to do a couple of things. The first thing, for the triangular prism, it's got to have the same volume as this. So we would need to figure out what the volume of this is. So the volume of the triangular prism is going to be equal to the volume of the square prism. And they don't give us the dimensions of the square part, so we can't find this one out yet. But we know the square prism, capital BH, is got to equal the triangular prism, capital BH. So the B in this one is a triangle. That's the base shape. And the B in this one is a square. Okay, so we need it for the triangle. We need the 1/2 B and H, the base and height of the triangle, which we weren't given. But because these are the same and we were given this side, we can find it. And we need the square sides, which we weren't given. Square, because they're both the same, it's base times height, but they're the same unit, so we just call it side square for the formula for that, and H. Okay, so the H's are the same H because they're both 12 in the problem, so we can really plug in 12 and divide by, we'll do that at the end. Let's find the base and the height of the triangle. So from the triangle, from the special right triangles unit, if you have a isosceles triangle, that means that these angles are exactly 45. So it's really a 45, 45, 90 triangle. So remember the ratio, if you're given the 45, 45, 90, is that the leg are these two, times the radical 2 is equal to the hypotenuse. Okay, if they give us the hypotenuse, we plug in that. And we divide by the square root of 2. So because these are both under the radical, we can just divide them first and then put the radical back over it. So we do 32 divided by 2, and we get the square root of 16. Well, 16, and then we put the radical sign back over it. So the leg is the square root of 16, which is just 4. Okay, if you didn't remember how to do special right triangles and you don't remember these formulas, no judgment. I mean, that's a lot to remember. What you would do is you would say that this is x and this is x. Because they're the same size, it's isosceles, when you do the Pythagorean theorem, you're going to get x squared plus x squared equals the square root of 32. Simplifying the left side, you get 2x squared equals the square root of 32. To get rid of a square root, you square both sides, so we square this. So we square this and we square this. So we're going to get 4x to the 4th actually equals 32. Oh, you know what? I forgot to square this at the beginning. So this is actually already just 32. A squared plus b squared equals c squared. I forgot to do that. So it's going to be 2x squared equals 32. Sorry for the timing. Dividing both sides by 2, we get x squared equals 16, and then taking the square root, we get x equals 4. So you can do it Pythagorean theorem, old school way, or you can do the other method. Either way, the base and the height for this are both 4. Okay, and then you just evaluate the left side. 0.5 times 4 times 4 times 12 is 96. So 96 equals 12s squared. Dividing both sides by 12, we get 8 equals s squared. Square rooting both of these, normally we could just do that, but this gives us a decimal and they want it in simplified radical form. So this is just a real quick practice problem of breaking down radicals. So 8 has two factors, 4 and 2. The square root of 4 is a perfect square. Square root of 4 is 2, so we just bring a 2 out, so our answer is 2 radical 2. 2 isn't a perfect square and it doesn't have a pair, so it does stay under the radical. So our answer would be 2 radical 2. Okay. Looking at the next one. Okay, this one, the 15%. They give you. Okay, let's see. The gate of Europe towers 15%. I'll let you read it real quick silently. Okay, so this height is straight up. So even though the towers, I'm going to draw it kind of like leaning as best as I can. But this tower height is the straight up height, so it's not the leaning height. And we want to use the feet one because these other ones are in feet. So 374, so you actually don't have to do anything with this. And then the 205 and 180, it doesn't matter which one goes where, but those are the base. And then there are two of them. So whatever you get for the volume for one tower, at the end you just want to times that by 2. Okay, so I'll let you get the volume of the rectangular prism because you should be pretty familiar with that. Okay, the next couple are working backwards for you to figure out using area and perimeter. Just to remind you, area is how much something covers. Those are our formulas that we've been using. Like triangles area is 1/2 base times height, rectangles area is base times height, versus perimeter, where that is like the length around something. So if you were to start at this point and walk this dimension, and then add the length of this dimension, and then add the length of this dimension, and add the length of this dimension. So that's the perimeter, and that's the area one. So that's your hint to do this, just to remind you. But I won't let you try these next couple. This one's kind of a fun one for you guys to try to figure out on your own. So again, I'll let you try that one. Assumes area of the plot, so it's just area of the trapezoid. Okay, I'll just rewrite the formula for you, but I'll let you try to figure this one out. Base 1 plus base 2 get added together and then times by the height and a half. I've only got a couple more minutes before the next class starts, so that's why I'm not doing as many of these. On number 3, though, they give you the height, and they give you one of the bases. They don't give you this bottom base. So if you already remember, some people will remember how to solve for the bottom base, but if you don't remember, the hint is to cut it into a rectangular piece, and then these two, because this is the same as this, these two pieces will be the same. So if you can use the right triangle and find the length from here to here, then that's the same as the length from here to here, and then you can get the whole second base. Okay, so you're using your Pythagorean theorem to find any kind of missing dimensions. So if we need this base here, we're going to use the right triangle here and use the Pythagorean theorem. Okay. Maybe this one have 1, 2. Yeah, most of the other ones are volume, but they're just application problems, and we've done volume, so probably the last one that I do. But again, you can always just log on to the Teams if you're having problems with any of these, and just message, and I can make sure I show that in the next class. So these worksheets are going to be due April 3rd, which is next Friday. So just make sure that you're getting them done. If you're watching this in 2020, April 3rd is when they're due. So make sure you're just getting them done before then and ask them questions early, not waiting until the last minute, so that I have time to respond in the Teams in our class meeting time. Okay, so a pedestal on which the statue is raised on a rectangular. Okay, so this one is just doing a rectangular prism again. It's 9 feet by 9 feet by 6 inches. So they're not all the same units of measure. And then how much is the cost? We want to see which one we want to use to convert it to. How much is the cost of the concrete in the pedestal if concrete costs $70 per cubic yard? So actually we need our answer to be in yards, so we want to convert all of these to yards. So we're doing feet to yards. There's 3 feet in every 1 yard. And then we're also doing inches to yards. So there's 12 inches in every 1 foot. So I'll help you do the conversions here, and then you're just doing the volume of this and timesing it by the $70. Okay, so the first one was 9 feet. So if we have 9 feet, we always start with the measurement that we're trying to convert. So we do 9 feet, and then we use our conversion table. So we have feet in yards, but we want the feet to cancel, and we want to end up in yards. So we put the yards over the feet so that the feet cancel, and we end up with yards. And then the feet was 3 and the yards was 1, so this is one we're going to divide. So we do 9 times 1, 9 divided by 3, so 3 yards. So this is really 3 yards on the bottom here. And it's also 9 feet wide, so this is also 3 yards. And it's 6 inches high, so we start off with inches. We want to use our conversion to get from inches to feet. And then we're going to do another conversion to get from feet to yards. So in chemistry, when you do dimensional analysis, you might have multiple conversions to make in the same problem. Here we're doing that too. So my computer timed out on me. Really quick. Okay, so this is inches in a foot, so there's 12 in every 1 foot, and then feet in a yard, there's 3 in every 1 yard. So we're going to do 6 divided by 12 and divided by 3. Those are both on the denominator, so we divide them both. Divided by 12 and divided by 3. I'm going to write it in fraction form, so I hit second arrow to get it to fraction, remember. So from decimal, if you have fraction decimal, it's the green button, you just do this, so it's 1/6 of a yard. Okay. So we do the volume of the base. Sorry, the area of the base times it by the height of the prism, and we get volume equals the area of the base is 3 times 3, and then timesing it by a 1/6 gives me 9 times the 1/6. So 9 times 1/6 is 1.5. That's my volume. And then they want to know what's the cost of the concrete if it costs $70 per cubic yard, so we just times that by $70. And we get that the total is $105. Okay. That's all I'm going to go through for this one because I'm out of time.